Hello everyone, my name is Leite Chou. I'm a senior student in Dixie State University CIT department. My major in computer science. Today I'm going to show you guys my senior project called Chinese compiler. Let's talk about the compiler first. Compiler is a computer program that transforms source code written in a program language into another computer language. Specifically in this project, we are going to use Chinese as the input source code. My goal of this project is let no English background people or children easily learn programming. So let's do a quick demo to show how this project works. So I'm currently using this English version file as my input file. So just be easier to demo for all of you guys. I would like to make some change. Like there probably need another integer x, and I would like assign that x to equal 100. Okay, and to compare those two variable. Forgot some colon in there. And each time, if sum less than 100, it plus equal 10 and print it out. So let's see what's the result. Okay, so here you can see it's from 45 because the first time you go through it is 45 and keep increase until it go over 100. At the first time it stop. So here I'm just to show you guys the code. This compiler is highly flexible. So no matter how you implement the code, as long as you follow the C++ syntax, it will recognize it. It supports a lot of cases so far. So this time let me use Chinese as the input language. Let's make something changed. So let's have two variables be declared. So I get another integer. There you go. And assign that integer to maybe 0, and that one to be 0 too. Okay. And then if, well, I don't use if, let's use while. While this variable less than 10 and the first variable minus 10, let's do plus 2 and print that out and increase the second variable in order to break the loop. All right, let's see. Okay, looks good. Let's see what's going on. Okay, cool. It's from 0 each time increase 2 until it repeat 10 times, break the while loop. So the result of this project seems to be easy, because I just gave a simple input file here and it compiles. But the principle behind this project is kind of complicated. Let's have a look at the structure of this project. So first we have our input file and it goes through the scanner. So scanner model is responsible for converting source language from a string of character into another string of token. So basically, the scanner will scan through the input file character by character, but here involves a strategy. So if I read character by character, so how this program knows now I'm reading in an integer type, and here I'm reading a name of variable declaration, and here I give this variable a number, and here is another while loop. So I use this state machine, this strategy to solve this problem. Let's have a look of our state machine. So here's my state machine class. So state machine, it is a finite automata. It tells the scanner class what the next step is. So for example, here is my sample code here. The state machine always starts with start state. So if the scanner is at right here and it read a S character, so it is a character, it goes to A state, and then it read another U, which is another letter, it repeat itself, it's still in A state, and the M the same, remain the A state, and then it reads a space. That means, okay, I'm currently at identifier token. That means what I wrote before, like SUM, is an identifier. And after that, it jumps back to the start state, go over again. It reads equal, it goes to assignment token. And after that, it's a space. And then this state machine tells the scanner, okay, that's an assignment token. And let's restart to that again. And it goes through the entire input file and identify every single chunk of code as token. So let's get back to this structure. Before I keep continue, I would like to tell you a trick about the Chinese input file. Different from English character stored in 1 bit, Chinese character is larger than 1 bit. Actually, those characters is under UTF-8 protocol. It's 4-bit for each character. It gives me trouble when I scan the input file, because in English, like I declare a variable, I can see integer my, right? From left to right, m, y, that's it. But in Chinese character, I would like say integer my, which is this character here. It's not a character, actually it's a word. So how this word works, it's like this. Here's the process in Chinese character. If I wrote a Chinese character, that's the order. So as you can see, there's one thing stack on another thing. That gave me trouble when I scan the Chinese file, but eventually I treat this entire words as one single character and then keep append the next this kind of word into it, then it will process correctly. Symbol table class is a class associated with my token. It stores the variable, and if the input file has redefined a variable or use a variable with no declaration, it will return errors. Based on the token class, parse class create a corresponding parse tree in order to do the interpret or the machine code. And after this process, our token become nodes, and our nodes connect by a chain. So here is what I mean, our nodes connected by chain. Here's an example of my parse tree, and all the square represent a node, and it starts with the start node. And the parse tree can be pretty complicated if even the source code is quite simple. Now we're getting into the most critical part of this project, which is interpret and the machine code. Interpret and machine code, they do the same job but in different way. Interpret call the C code to do the calculations, and the machine code go deep into the assembly language level to do the calculations. So here is my while statement node, both interpret and the machine code. And interpret is pretty straightforward. It's a while loop, and it checks the expression node first, called evaluate, and then it do the specific statement node job, which is the inside of that while loop. But the machine code is way different than that. Here is while statement node, a function machine code. it takes one input parameter, which is the address of machine code. It's from instruction class, which is I wrote them down there. First, it assigns the first place to be the address, because the input parameter is a machine code address. It will change by the process during it here. So I need to record the address to be able to do the escape or jump. So first off, I need the address here. And after that, I do the M expression node evaluate. It's kind of similar up here, but it takes the address and it's not using C++ reserved word anymore. So we're not going to see well anywhere in here. It will go through deep to the assembler level to do the job. And after that, I need another address called jump address. It records the address and also to see if the expression is 0 or 1. And if it is false, it's going to jump. But in this case, it won't know where to jump until I set this offset here. So I got address 2, which is right there, and address 1, which is right here. That means if this machine code expression is false, it's gonna jump down here. So it will totally escape the thing process between it, which is my statement node, which is right here. That's the same logic way with the while loop, right? If here is false, it will escape the statement node. And then let's see what happens if it is not escaped. It will keep record the address 1 and it will do the machine code for statement node and record the jump address 2. And this jump do not know where it jump until we set this offset to jump 0 minus 2, which is from here back up there, and to do that over again. That's what while statement is supposed to do. This project involves 20 files and over 3,000 lines of code. It is pretty easy output, but complicated inside. The most tempting point of this project is the structure. It took me over 150 hours, so hopefully you like it. Thanks for watching.